In this video, we're going to discuss a review of an MiHPT log, as well as the QA testing and other information that is contained within the log. I just want to show everybody how to access that information and what you can tell about QA testing, making sure that the system is working properly, and how you can check on operators' logs. Again, this is an MiHPT log. We have electrical connectivity on the far left, HPT injection pressure, and then three detectors, a PID, FID, and XSD. You can see that we have big responses on the PID and FID. One of the main things you really need to look at with MIP detector data is what are the scales at. So you can see we have very little baseline showing on the PID or the FID. Pretty strong signal coming out. These responses, I'm showing 5 e to the 7th, and if I put, and this one, the FID is also e to the 7th, I'm going to put that to the same scale. So those are showing the same scale, 5 e to the 7th. Now the XSD is much smaller than that, and you can see much more movement of the baseline, which some people can get concerned about. It really doesn't bother me that much unless we're trying to see really low levels. This is now 1 e to the 6th, so still well below the scale that we're seeing on the PID and FID. That shows me that there's very little, if any, halogenated compounds, which is what the XSD is going to be looking for, not the hydrocarbons, which is what this is showing. The PID and FID are responding to hydrocarbons. This is a former gas station property. Making sure your scale is appropriate for the type of site and contaminant levels that you're looking at. Okay, now here this is 1 e to the 7th. We can really see that there's nothing showing up here in relation to the magnitudes that we're seeing on the other two detectors. As far as position, these responses are coming in right in this area where you're transitioning from silts and clays down into a sand. The lower the connectivity, the lower the HPT pressure, that's typically where you're going to see more permeable, coarser grain materials on the EC, your sands and gravels. As the EC and HPT go up in readings, that's typically less permeable materials, silts and clays. We have pretty good collaboration between the EC and HPT pressure in the surface. In this case, I'm in metric mode, so in the top 8-9 meters. As we go down, we're getting some larger responses on HPT that aren't as strong on the EC. That could be that there's maybe cemented sands near the bottom. It could be weathered bedrock, things like that, that would be less permeable but not have as strong of connectivity. A couple other things I want to show here. If I come over to the lower right corner and left click on the View tab, and I'm going to click on the Response Test tab. This is my chemical response test that was done at the beginning and end of the log. What I've done here, normally you won't have this baseline and the peak drawn on here. You can put your cursor on the baseline somewhere here where you get a pop-up tab. In this case it says PID 134, that's the time, and then the response level that we have there. Right click, and I'm going to set as the baseline, and then normally it'll just draw a line to the highest point on the graph. If it's not where you want it, you just come over, get a data point, right click, and I would set that as my peak. So that's what I've done in these two locations. So I don't want to have it up here. The type of response test that we did here, we got a big peak at the end of it. I typically don't use that, but we'll use some other high point in the peak. And you can see here that your peak height from the baseline that was drawn up to the top point in the peak is 46,000 microvolts. This one's 50,000 microvolts for a 5 ppm benzene. If the operator put this information, the compound and the concentration, that information will populate in here. So we have very good consistency, and that's what we're looking for here in the response test data before and after the log. Some operators may do multiple tests. This one here, possibly, I'm not sure if this was a blank or another 1 ppm standard. Possibly it wasn't written in here, so I'm not sure what that one is. If there are multiple levels, they should be writing out the different concentrations, and it's also a good reference showing that increasing concentrations will give you increasing responses. This is on the PID. If I want to look at the FID, FID is not as responsive at those low concentrations. It's not as sensitive, I should say. The FID is not as sensitive as the PID or the XSD for halogenated compounds. Since we're running benzene, the XSD is not giving us much response at all. There's some movement, but I'm not really concerned about that movement because this is a hydrocarbon site and we're running benzene response test. Now I'm going to close that out and come back down to View and left click and go to the INF file. And this will tell me with the name of the log, version of software we're using. So this is an older version. This is 1.7. We're now on to a higher version than that. And this is the build. This is based on the year and day that the software was completed. Here's our pre-log QA test for electrical connectivity. So we see what our target values are for the high and low value, what the actual values were, and that we're within our 10% window and we're passing. So that's good. Here's some information about the site and tools that are used that were asked at the beginning of the log. So it tells us which probe type was used, the location, what type of string pot and rod length we're using. Here is information on the chemical response test that was entered in, the trip time that was entered in for the chemical response test, how long it takes that chemical to go from the membrane to the detectors. This is the HPT reference test, which is done to confirm the HPT sensor is working properly. We measure the pressure of a 6-inch water column at the top of a reference tube and 6 inches below where the water can flow out of valve. These tests are performed with the water flowing and without flow. The result of the compared top and bottom tests are expected to be within 10% of 0.22 psi or 1.5 kPa, which this test shows. Now we're going to see the alarms that went off. If there's anything that I'm concerned about, I can look at that and pull up some other graphs in the log. We also are showing what our ending time, I believe up above we had our beginning time as well, but here's the end time and the depth that the log went to, and also our post-log response test. Also, if there's any information that was written into the log, user notes, specifics about something that was going on with the log, this is where that would be. One last thing here, under the view dissipation tests, there was a dissipation test that was run. We're going to load that up. This is with HPT flow going when the pump was shut off, where it stabilized. I'm going to close that. So here there were 3 tests that were done, and this is a good check. With 3 tests, we've got a straight line, which is a good indication that the tests were performed to full dissipation. And if I go and look at the static water level, that's just left clicking on this. It was up at absolute static pressure, went down to static water level. This is telling me that between those 3 tests, I'm within 0.2 meters of each other as far as the static water level. So that means they're all fully dissipated. Here's the absolute piezometric pressure. If you don't have that on your graph, you can right click on this graph, go to secondary series and select absolute piezometric pressure. This is where the dissipation tests were performed as you subtract the pressure of water, and when it intersects atmospheric pressure, that's your static water level. I'm also going to add a graph, left click on add graph, estimated K, and enter that. I'm going to go back and readjust the XSD scale settings. Here's a good display of that particular log and how I may choose to print this. This should hopefully give you some keys for looking at MiHPT logs and making sure that everything's looking good as you're reviewing the logs.